Great. Thanks, Cindy. And thank you to everybody who organized this for having me here at pretty short notice too. Thanks. I just wanted to say hi, and then I'll just stop my video and hopefully you can see my screen. Let me know if you're not seeing it, but I'll assume you are, and I'm going to go ahead with it. Right, so I just wanted to give an overview of what we're producing as openly available tools and services for everybody to use, whoever wants to use them. This is work done through CGIAR's big data platform for agriculture. But again, everything that I'm presenting here is open and free for you all, anybody to use really. I want to start by harking back to a slide that Andy had yesterday in his keynote, Future Farms, Small and Smart. And he had this sort of overview of the digital farm, really. And what I want to sort of pick up on and take forward is Future Farm's current research, current and future crises. And we're weathering a big crisis right now. And I think we've all seen the importance of agility and quality in data and interoperability in particular, because we need to be able to find data. We certainly need to be able to interpret it and interoperate with it. We need to be able to aggregate data sets. We need to be able to visualize and analyze data. So I'm going to go through this presentation today from sort of with, putting on my user hat as much as possible to try and show you what sorts of questions we're trying to answer. And I hope you can see all of my slides. So if there's a hang up, please don't hesitate to interrupt me and let me know. Moving along to my next slide. What I want to start with is kind of a grounding of what we're developing as a sort of a data ecosystem. And this is the Guardian data ecosystem. And it has all of those pieces that I mentioned earlier, you know, the finding data, the interpreting data, aggregating it, visualizing it, analyzing it. Here, this is sort of the heart of that ecosystem. And this is the data discovery piece, the finding data piece of it. These two cogs here, which I'll treat separately as I go forward, are both to enable us to interpret that data better, to interoperate, and to be able to aggregate it much more easily. The bottom cog here, data exploration and mapping, as the name implies, is about being able to visualize what you do find. You know, we need the ability to be able to draw pictures and see in pictures. And this is what provides that. We're trying to build that out much more. And then the ability to analyze that data. So being able to do much more plug and play. And for all of this, the holy grail for me has been what's been done in the biomedical domain, the NCBI, the National Center for Biotechnology Information, and its mirror sites in Europe and in Japan. So what we're trying to build is this very complex functionality all the way from data through to the analytical product. It's not easy to do. It's very complex, particularly because agriculture is quite complex. You know, it spans scales and disciplines and can be difficult to do. But I think we've made good progress on it. So diving right in, the question, where can I find data on whatever, X, Y, Z? This is the heart of the Guardian data ecosystem, as I mentioned. So I can go to Guardian, which is guardian.bigdata.cgiar.org. Currently, it has about 170,000 publications and almost 30,000 data sets in it. Not all of them are open, but a lot of them are. Most of them are, I would say. And you can do a search like this. Andy showed this yesterday in his keynote. The reason I like to use that search is because it shows you sort of all of the different sources that the data is coming from. We also have data actually visible, pointing to data sets that are sitting in USDA's Ag Data Commons, which Cindy, I think, oversees essentially. That's not showing up in the search, but all of the not all, but a number of CGIAR centers, DFID, USAID, the Indian government's open data portal, and World Bank do show up here in this search. So that's kind of nice that all of this data plays in the same sort of sandbox and is filterable and diceable in different ways through these top filters and these side themes on the left here. When you do look at a data set, you see, the source of the data, the authors, a summary, and all of the metadata that comes with a resource, whether it be a publication or a data set, that metadata is enriched by Guardian. So whatever is available is used for metadata enrichment. You see a license, of course, terms of use. Can you use this or not? You see a link to the actual data set, because we're not actually holding the data set, we're just making it discoverable. And then the enriched metadata allows us to do things like this, provide a little bit more geographic context for it. And then going further down, it also allows us to do the keyword cloud sort of thing. And some of those keywords come from user-entered terms, which could be Agravoc terms, as Kristen just presented. They could be ontology terms. But the point is that they allow you to hone in, dive in, they're clickable. So that, you can go in and click on nutrition and you get, you're basically doing a search for nutrition there. At the bottom of this, you also see the relevant publications. And again, that's the enrichment technique that partially allows us to, the algorithms in Guardian to do this kind of thing, where you're getting more context on the data set that you're looking at through these relevant publications. And when you're looking at a publication page, you'll see relevant data sets there. Lastly, a lot of people here have talked about fair scoring. We've implemented that so that each resource now in Guardian comes with a fair score. This is not some kind of policing. This is just a way to sort of enable you to determine how interoperable, for instance, is a particular resource. And interoperability is extremely difficult. It's not easy to do. We're making progress on that in that realm, but it tends to be the sticking point for all of this. So we've enabled things to be scored, but you might ask, I want to actually make my data fair and upload it so that it plays with all of the data in Guardian and others can see it and use it and interact with it in the same way. How do I do this? So that's another user question. And for this, we're going to move away from the heart of the Guardian data ecosystem now and look at the ontology and metadata tagging tools that we're developing. So this is part of a data upload and fair workflow. So within the next month, you'll be able to visit Guardian and be able to upload a data set. So if you don't have a repository, for instance, or you just want to upload your data somewhere, you can do that with this in a very easy step through fair workflow that'll give you the ability to make your data fair as well. We've also included in Guardian this sort of guideline, these sorts of guidelines for each of those fair data indicators. So for the F, the findable, to make something more findable, what do you have to do? And this is a blow-by-blow account of how you can get from sort of a level 1 to a level 5 to make it more findable, to make something more accessible, to make something more interoperable and reusable. So there's an F, A, I, and R as part of this. I'm just showing you one of them. And the link to that guideline is out there and you can use it. So here's another kind of question. It's great that I can make my legacy data fair, my historical data fair, or new data that I'm collecting, I can dive in and after collecting, make it fair. But I would actually like to make my data fair from the moment it's collected. How do I do this? So for this, we focused on the agronomy domain, but CGIAR has ongoing work and already has breeding-focused field books that allow you to collect data, breeding data, crop breeding data that's already fair because they're based on ontologies. This is an agronomy field book called the Agronomy Field Information Management System. Andy showed this slide as well. That allows you to make your data fair. And I've included a link here. You can go in and check it out yourself. All of this, again, is open and free. So let me just dive into it. This is just to show you the home screen, but what I want to focus in on is something that Cindy said just a few minutes ago in the chat. If tool builders do their job well, it may not be necessary for field workers to think about ontologies at all. And this is very well said, because this is exactly what we're trying to enable through AgroFIMS. We don't want agronomists and researchers to have to think about what an ontology is and how they have to interact with it. Forget about it. Just use the field book. If you're an agronomist, you'll be able to use it. So that's where we want to get. My hope is that we're pretty close to that, if not already there. But then I have my head buried in this all the time, so maybe I'm overestimating. Just to give you a sense of what this looks like, when you're actually, when you dive in to go create a field book, you will first go to a sort of a map interface and hone in on where you want to actually position your site. So you can do that first, create a site, and then when you go to site at the top here, you'll see that. That site come up as a list. But here, the experiment and personal tags that you see at the top of the menu here are ways to actually put your metadata in from the start. And if you look at the arrow here, type of experiment, what you see is a set of choices, and all of those are ontology terms, but you don't need to know that. This is very understandable. So you just choose what's appropriate and go forward. And everything in Agrifems works like this. It's very understandable. And you should just be able to use it. So you go through these tabs, you set up a, you specify your crop, you specify whether it's an intercrop or a monocrop, relay crop, etc. All from the ontologies. You set up your experimental design, statistical design. You go through your management practices, your weeding, irrigation, mulching, residue management. You can do all of that or none of them, depending on how complicated your experiment is. And you set up what you're actually going to measure. And there are some other modules here, weather, soil, crop phenology, etc. What you end up with once you do this is a field book that looks like this with multiple tabs, the first one of which is a metadata tab, and the others go through and lay out what you've already done. You ship this field book out to an Android data collection app, again, openly available on the Play Store, Android Play Store. It's called KD Smart. So you download that on your phone or your tablet. You can bring this field book in, and then you go through and collect data. And once you've collected the data, you ship it back to Agrifems if you want. You don't have to. You can do whatever you want with it after that. But if you ship it back to Agrifems, you can do a quick statistical analysis. And once you do the statistical analysis, Agrifems will give you a very nice statistical report like this. This is actually from Agrifems. So it's we've tried to add a lot of value for researchers, make it simple, stupid, that adhering to that principle, and then giving back a lot of value add. So the metadata schema adheres, it's based on Dublin Core essentially. So, it meets with a lot of institutional repository requirements. So that's useful as well. So the question is, you've told me a lot about what a semantically enabling data. What can I actually do with this semantically enabled FAIR data? So again, diving back into Guardian, under the, if you do a search, you'll see a data exploration tab pop up on the next screen from the home screen. And you see the semantically enabled data tab here. If you click on it, you'll see some sort of demonstrations of what you can do with semantically enabled data. So here I've said, all right, Guardian, please give me data for yields of not improved sorghum. So I've chosen sorghum from a drop-down list of crops here. And I've chosen, by clicking on selection tab there, I've gone into a map view and I've chosen wherever that data exists for, which is Mali, Ghana, and Tanzania here. I've clicked on go. And what I see when I do that is that Guardian is using the data that's semantically enabled. It's able to query it very quickly, and it brings me back aggregated data. So it's actually aggregating the data for me across 3 different data sets. They're from the same project, but they've been collected by different people in different countries, and this has saved the researcher several months often of work. So it's quite useful to have semantically enabled data. And that's just several people on the chat were sort of saying, well, I don't really get what this will do for me. So I'm showing you the kinds of things semantically enabled data can do for you. What else can you do? Well, can I visualize and interactively query map data? So this is the sort of the visualization of data from that first slide that I started out with. Again, in Guardian, when you go to the geospatial data exploration piece, you'll see about 30 some odd crops. These are global model estimates from a model data set, a very large data set. I'm querying here for rice and wheat, and I've chosen one of 5 or 6 parameters, in this case rain-fed yield, globally, and I've mapped that globally for both rice and wheat. You can see the legend there. And then what I've done is I've taken the pin from the left, my red arrow is pointing to it. I've just moved my cursor, picked it up and moved my cursor over to Mozambique and dropped the pin on Mozambique. When I do that, an interactive box pops up and tells me what the rain-fed yield for Mozambique is in terms of both, the summary statistics essentially. But what I can also do is I can click on this little wheel there, and when I do that, it links me to it's linked to another large database called Data Africa. And again, all of these things are open. So you can go in and get a lot more statistics for Mozambique. So we're trying to sort of link everything that we can to bring you a large knowledge base, a large pool of data that you can now interact with in one place. The other thing you can do is you could go to this, now my arrow is pointing to this polygon shaped thing here. You go there and you can draw a little polygon. I don't know if you can see that on your screens, but it's a very light green sort of polygon that I've drawn there. And now I'm querying the summary statistics in Mozambique for that particular area. So I want to know the rain-fed yield of rice and wheat for a particular area. I can do that. And I can get a pop-up box with the data. So these are the kinds of things that you can do when your data is really nicely described. And we've built them into Guardian as use propositions. And value propositions to demonstrate the value of doing all of this and committing to it. I need data to understand variation in crop response to fertilizer across sub-Saharan Africa. This was work done by a team at UC Davis. Andy mentioned that yesterday as well. What you see on the left is the variation in yield by nitrogen kilograms per hectare. But almost more interesting is what you see when you actually map that. This is data from, they found about 200 plus data sets in Guardian. They threw out a few, and in the end, they used about 130 plus data sets to do this work. They had to do a lot of still data wrangling, cleaning, processing, interpreting, because the data is not all fair. In fact, most of it is not fair, or as fair as it could be. But you can do this kind of mapping where you start seeing patterns now, spatial patterns, once you have the data. And this is showing you crop response to 50 kilograms per hectare of nitrogen on the map there. So it's really powerful what you can do, once you have well-described data. So now moving on to sort of the last plug and play part of this is being able to analyze it. So you can find it, but now you want to be able to analyze the data seamlessly. Is this possible? And the answer is yes, because this is a very new offering that will come, that'll be on the production system available again in a couple of weeks. Labs.sia.systems, you can already dive in and check it out. What we've tried to do here is to pull together the functionalities of a variety of different kinds of tools that people are forced to use now, researchers. Things like Slack to collaborate, email, Dropbox, etc., to exchange data, but it's not secure exchange, so you worry about it if you have sensitive data as part of your data set. GitHub to manage code, and Jupyter, so Python and R-based analytical platform for data analysis. We've pulled all of this together in CG Labs, and I really encourage you to dive in and try it. It's all underlain by Globus. So when you sign in, you have to set up a Globus account. Globus is a software developed at the University of Chicago in the US, and it allows you to securely exchange or transfer data sets. So you don't have to worry about data security there. So CG Labs is pretty complex, but what you can do is things like this. So this is my space. This is I've set up a space for my team, say, which right now has a few members, very few members, because it's just a test space. But you can set up a lab space or a field team space for your team. You can find data, so it'll do a search on Guardian. Here I've done a search for potato variety, and I see all of these results. I can click on these boxes for the CC BY or CC0 data sets, which are the least restrictive licensed data sets, and I can save them. So once I save them, I find the data, I save it to my team space here, Medha's team space, you can see that there, and I can now securely share it with others. So it's with my team members, essentially. Here's a bunch of data sets, you can see those. What I can do next is I can also click on this geospatial exploration. I go there and I have the same things you saw in Guardian. The top icon there that you see is the crop production data set I showed you. The bottom one here is a very large 7-8 terabyte climate data set called CMIP6 in this case. I'm not going to dive into the particulars, but the point here is you can choose one of several models, climate models, I've chosen maximum temperature there. And I can do the same sorts of things. I can run this from, the data exists from the 2030s all the way through the 2080s. So I can run it as a video. I can pause it at any time. I can take the pin and drop my pin on any particular country to look at the max temperature for that country for that particular time slice. But what I want to show you here is a different functionality, which is the save icon here, which allows me to download the data directly from here. So that's quite nice because I can choose my parameter. I can choose the range, the year range. I can choose the sort of the socioeconomic sort of model scenario there, the constraint. I can choose the model and I can download the data, which is really nice to be able to do directly. I can also analyze the data. So just quickly here, when I click on analyze, I get taken to a screen that looks like this. You'll see, a link there up there for Git. That's sort of a link out to GitHub because you can develop code and then upload directly to your GitHub repository or pull down code from your GitHub repository and work with the data sets that you found from Guardian. So now here's that seamless sort of give me the data and let me do something with it kind of functionality. This is not for everybody. I understand that because you have to know R, you have to know Python, but we're trying to make build-in pieces that make this easier to use. That'll hopefully come as we go along. But for those of you who do understand this, here's some data on the left here. I've called on WOFOST. WOFOST is a crop model developed at Wageningen University and research. And you can pull that and do stuff with it. So, and you can plot as well. You do need to code in R though for this. So you can do that. And another commonly used crop model will soon be available, DSAT, will soon be more will offer more plug and play opportunities. And that leads me to work that we've been doing with Cheryl Porter and colleagues at the University of Florida and part of the AgMIP project, the Agricultural Model Intercomparison and Improvement Project, to answer this kind of question. I'm a researcher. I need to evaluate and recommend sustainable intensification practices for West Africa. How do I do that? Well, what I can do, this is Ava here on the left. She's done a Guardian search and found 37 field experiments with a variety of different crops. Out of that, she's been able to use a few. And what she's done is data variables in those few data sets perhaps were mapped to terms from the ICASA data dictionary, which is commonly used by modelers to describe data variables like, electrical conductivity of the soil or yield or whatever it is. But you can also map to agronomy ontology, crop ontology, unit ontology, etc. And then what the team has done at the University of Florida, AgMIP team, is to develop these what are known as translation tools that can take the data that you find in Guardian, render it model ready with not too much pain, and then that qualifies it, that makes it available for models like DSAT. So we want to build this kind of data to decision support analytical sort of solution seamlessly. And we're in our early stages of this, but it's promising and we're getting there. So now I'm going to change gears and sort of dive into a quick set of use cases, which I included because I know that this is going to be shared and you can click on these and get to them if you want. I need help planning for data management. Well, we've developed a data management checklist, which might be helpful. You can take it or leave it, take whatever is useful out of this for you. You don't have to use it all. And there's an exemplar template as well, a data management template. There's also something called the DMP tool online, which I forgot to include it here, but you can check it out. Just Google DMP, Data Management Plan Tool, DMP tool, and you should be able to find it. But these things might be helpful if you just want to start out understanding what you need to do to plan for good data management right from the start of your project. How do I prioritize which legacy data sets to spend time and funds to verify? We have a data prioritization matrix, which gives you a nice sort of analysis based on the value of the data set, the cost of the data set, and the risks associated with that, making that data set open, essentially. So that's something you may want to take a look at. I'm writing a proposal, but I have no idea what to budget for data management. We have a budget template that gives you sort of, line items where you can look at, it sort of sparks your thinking on what to budget for. You know, it might be helpful, it might not, but I'm sharing it just in case it is. What can I do to ensure data is collected and managed consistently across project locations? So we have an example standard operating protocol there, which you can, again, take or leave. I should qualify this by saying that many of these tools are focused on agronomy, because I'm an agronomist, a cropping systems agronomist, and a soil microbiologist by training. But you know, you can certainly modify this. I would imagine that starting with something in hand is a lot easier than starting blank. How should I annotate my data? Marie-Angelique is here, so is Abenet from CGIAR, and Bosun I saw as well. They're all part of the metadata working group led by Marie. They've developed what we call the CG Core metadata schema, which is based on the Dublin Core. It's broadly applicable to agricultural data in general, and it's available for anybody who wants to use it. And there's a reference guide associated with it, which is should make it simpler to use. There's also, and this is built into our FAIR workflows as well. There's also the AgroVoc that you heard about, which we use quite significantly at CGIAR. And we use, of course, the crop ontology and the agronomy ontology, and a number of other ontologies that Clément mentioned in passing as well. We're enhancing livestock and fish ontologies, and we're in the last sort of home stretch of building a socioeconomics, the beginnings of a socioeconomics ontology as well, to make all of this stuff interoperable and interpretable more widely. And again, the idea is to build these into tools so that, to the extent possible, you shouldn't need to know what an ontology is and what it actually does. Standard data collection sheet, again, this is this is primarily agronomy focused, but the principles here are much more broadly applicable to all data. So have a look at it. These are all clickable links that I've included here for you. And this is the rest of that data sheet. You see the first tab I showed you down at the bottom was the metadata, and then you have a protocol visible there. You have the descriptions of the variables, which I'm showing here. You have raw data and field collection sorts of things, looking quite similar to what Richard was showing you. And the idea here is to include URIs and then share the data, of course.
Medha, I'm sorry to interrupt. We do need to wrap up.
Okay,
So
I'm done. This is my last slide. So,
okay, great.
So, well, this is just some more stuff: ethical data management, data processing, wrangling tools, anonymization tools. Have a look at those. All of this stuff is, I'm sorry, I'm on there for front and center, but I couldn't convince them not to have me there. So this is best practices for open, fair, and ethical data. And we started out talking with Ima Chipo, who was then at CTA, and Wageningen, and I think Godin, they collaborated on a sort of a 101 of open data course. We started talking with them and realized actually in the end, we weren't going to be using much of what they had developed, but we built on top of what they did. So think of this as a 201 sort of, next level up, open, fair, and ethical data. It's focusing mostly on the fair and ethical pieces of this. So this will be available soon through the Tech Change platform. And with that, I'm going to end. This was an overview of all the tools and services. Again, all of them are openly available. You may want to dive more into them, and you may have questions as you go along about how to use these, how to collaborate with us. Please don't hesitate to contact me. That's my email up there. Thank you.